Hello friends, welcome to our channel. Let's look at today's daily challenge problem, length of longest Fibonacci subsequence. In this video, we are going to solve it using dynamic programming. So we know that DP actually has different representation formats. So here we are going to present three formats. So one is tabulation, the second is chain and grow, and the third one is using dictionary. So I will not read through the problem statement, but I want to emphasize 3 points. First, here we are treating subsequence, not subarray. Second, and the array given is strictly increasing, right? And the third one is that the first constraint, the upper bound. So this gives us the problem size. So without further ado, let's look at the coding. And in between, I'm going to explain the logic. So the first version is going to be tabulation. So this will be a elementary representation format for dynamic programming. So here first I'm going to introduce this in just for convenience. This is a length, and then I'm going to introduce a maximum length. So this is a variable that we are going to return its final state. So then I'm going to initialize a DP table. So here I'm going to initialize a 2-dimensional DP table. So for this dummy index in range n. So notice that for beginners, actually the initialization of higher dimensional list is not trivial. So notice here, inner side, I'm using this 0 times n essentially. But for the outer side, I'm using this, right? Not multiplied by n outside. The reason is that list is mutable, and this way we create different references for the n lists, right? This is important. So with that said, because we are going to check membership, also I'm going to initialize a value to index, right? So basically num idx for idx num in enumerate array. So here I change this one to be a dictionary, because for dictionary or set, the membership check will be a one operation, right? So with that said, let me first do a interpretation, right? So dp previous and current. This will previous and current will be indices. I'm going to be store the length of Fibonacci-like sequence ending at indices current. So this is the pair. I mean the last two numbers in the F sequence ending at these two indices. So once we have this, we can do DP update. So this DP update. So for current in range n, for previous in range current. So I'm going to first let's assume we want to examine the potentials. Let's see, array at current, array at previous. If these two numbers were the last two numbers for a valid F sequence, then the first previous one will be array current minus array previous, right? This is from the definition. Let's check this chain. So basically, let me first get diff. The diff will be array previous minus not previous current minus array previous, right? So then let's get the index for the diff. This is the first number, right? So the value to index. Then we use the get method of a dictionary. So then if let's use this key. If this key not inside the dictionary, we're going to return some default value. Let's use -1 here. Yeah, we are finishing the preparation. Now let's check if this guy is in the array, right? And also if this guy is in bound, right? So what we want to do is actually this. So dp previous and current would be dp previous idx up to previous add 1, meaning that we can extend if first we need the previous index inbound greater than or equal to 0, and we need this diff, this number. Diff is less than this previous, right? Array previous. That will be sufficient because by definition the current has a larger index than previous. It's naturally larger than the number at previous. So this is the one. And otherwise, so this is the condition. Otherwise, we're going to set it to be 2. So I hope you can pay attention to this set 2, because in the third version, I'm also going to use some initialization using 2. So once we update this one, we can update the maximum length. It will be the previous state maximum length, and also the current one, the previous and current. So with that said, let's update this. Let's return this, not update. Return maximum length if maximum length is greater than 2, right? Otherwise, we return 0. So that's the full logic. Actually, the code is not very long. To just translate this requirement to be the coding format. Let me first run it to make sure it works. Yeah, it passes the generic cases. This will be the first version of our solution. So here, basically, 2 points to emphasize. We need to check things inbound. This is the crucial. And also, in order to accelerate a little bit, we made a dictionary value to idx dictionary. So let me now let's move to the second version. Let me copy this part. And then I'm going to change this one to be version v1. So now what we want to do is we do chain and grow the length. So this is a very typical trick. So what we do, first I'm going to make a set. So actually this set will have the same number of elements because array is strictly increasing. But set, again, if we do membership check, is O1 operation, much faster. And also I'm going to initialize a maximum length, originally 0. And the 0 is due to this. If it does not exist, you're going to return 0, right? So now I'm going to chain the things together and do the grow of the length. So for I in range m, for j in range, so I plus 1 to m. And then I'm going to consider these 2 numbers, left, right, and also I have a temporary length. So the left will be array I, because I is smaller in index, so the value is smaller. Array j. I'm going to set this temporary length to be 0, because I don't know if we have a valid flag sequence or not. So then if we regard this 2 as the first 2, then if we want to grow, the next number will be left plus right, right? So then what we do, we grow the length. Well, left plus right is in num set. So this is the inbound check. It's like here, but in a different direction. So what we do is we can temp length. So we can increment by 1 because we know at least we have this number. And then we want to do a shift, left, right to be left, not left, right, and left plus right. Then once we exit this loop, we actually growed the Fibonacci sequence starting at index I and j, right? The first 2 numbers, indices. So then what we do, maximum length will be maximum length, temp length, plus 2, right? If you checked, oh, this does not inset, so you are going to get at most 2, right? Now we just return this. I can copy this part. Let me first run it to make sure it works. Yeah, it passes all the general cases. Actually, if you compare these two, the only difference is that the direction we check, right? So here is backwards. So here is forwards. So if you have done problems in leetcode, like find the nth Fibonacci number, so you will see this pattern, right? Due to this pattern, we can write an O1 solution to that kind of problem. So that's what I want to see for the second version. Now let me copy this one. So I'm going to change this one to be version v2. And then I'm going to use dictionary to help address this problem. So for this, I'm going to, this actually is sort of the same as the first version, but in a different representation format. But also we can introduce some early stopping or bounding condition, which will accelerate a little bit about the overall process. So what we do is like have a lookup. So you can have a dictionary. So this will store the for different the Fibonacci sequence starting from different numbers. So then I get a result. So this will be the variable we are going to return its final state. What's wrong? So result equals 0. So now let's say for position num in enumerate array, and then for so let's see the lookup table. Let's first initialize it. Lookup. So starting from this one. So I'm going to make a collections default dict. So here I'm going to map everything to be 2. So actually, if you still remember the comment when I set 2 here, you should be able to think of the reason. So now let's grow it. So for previous position in range, so we are going to look at the previous one, position -1, and then we are ending at 0, but with decrement -1. Then the previous number will be array and previous position. So in other words, we are considering these numbers. So the num, the previous one will be previous. So then if we check the further previous one, it will be actually num minus previous, right? This is due to definition. So now let's check that to see if we can chain them together. So we get the previous, then previous 2, further previous will be num minus previous, right? So first, if previous 2 is greater than or equal to prev, so we just break. We don't need to check because we need this number strictly less than previous. Because we know the index corresponding to previous is smaller than the index position corresponding to num. So this naturally we have previous is less than nums strictly because of this assumption. We don't need to check that. So this is one thing. Another thing is that if previous 2 not in lookup, so we cannot chain them together actually. So in the language of the second version, we just continue. So now let's update. So we have lookup. So we have num. So then we further set this previous, right? So then this will be the length at lookup previous further, right? So it's like reversed from the version we went, right? But it's the same idea. So add 1. But I don't need to do the bounding condition because here I have already done it. And due to the initialization using default dict. Then we can do is max result, and then let's copy this one. So then what I'm going to do is to return the result. So that's the third version. So actually, I use quite a lot this trick when we do dynamic programming, right? So actually, for the first version, in order to use this, you can also use a default dictionary, right? So now let me first run it. Lookup is not defined. Let's see. Lookup. I see. That's the op. Let's run it. Yeah, it passes the two test cases. Now let's look at the generic case. Yeah, actually, it's a little bit faster than the first two versions due to the stopping conditions here. So I guess this is the third version. So with that said, I guess we are finishing the 3 versions of dynamic programming. So now it's a time to make some summarization. So here we present 3 DP formats. One is tabulation. This is the the entering format for doing DP. Then I do chain and growth. So this is a very plain technique or very common technique. The third one is using dictionary. So using data structure to help address problems is a common practice. So with that said, I guess that's about it for the current video. So I guess the video is already very long. So I would say if you find this interesting or useful, you are welcome to share with your friends or classmates, and you're also welcome to look at our videos in the channel or playlist. Thank you.